Okay, so now let's apply this complex number system to the solutions of quadratic equations. Okay, so solve quadratic equations. Okay, good. Quadratic equations. Every time we have to adjust the focus. In the complex number system. Uh, well, so far we complex number. What is complex number? A plus bi. What is I? I squared is equal to -1. I squared is equal to -1. But what happens if we change this -1 to be other negative numbers? Right? So we want to extend. So basically we just solve this equation. What happens if we have other, for example, other negative number? X squared is equal to other next number, negative number. What is the solution? How do we define the solution of this one? Okay, so that's our first definition. If capital N is a positive number, positive, real. Whenever we see positive, it is always a real number. Complex number has no positive or negative. We define the principal square root. The principal wow, it's bad. Square root, the principal square root of -n. Okay, so principal square root of -n, one of the answer solutions of x squared equal to -n, denoted by square root of -n as, okay, so what is a solution? We define it square root of -n to be square root of n. You see, this is a square root of positive number, and then times I. Square root of n and then times I. Okay, so this is our definition, where I is the imaginary unit and I squared is -1. I squared is negative. Okay, so that's our first definition. Well, this definition, first of all, makes sense, right? Because of we know that if we have two real numbers, if a, b are two real numbers, then a times b quantity squared is a squared and times b squared. What happens if we have square root of n times I? Here n is a positive, remember that. Assume we also have such property, then we will have square root of n squared and times I squared. Square root of n squared is n. I squared is negative sign. So you see here, this is exactly the solution of x squared equal to -n. And that is the reason behind this definition, why we define square root of -n to be square root of n times I, when n is a positive real number. Okay? And there's one thing, try your best to clearly write this is square root of n. This is one number, and then times I. Don't put this I so close to n, it make it looks like it's a square root of a, you see? This is wrong. Don't make the square root symbol too big to cover I. This is the wrong notation. It's a square root of n and then times I. This is the right notation. Okay? So when you write it, make sure it's correct. Okay, so now let's see. First one, if we have square root of -1, then based on the definition, this 1 is n, or capital N is 1, so you will get square root of 1 times I. Square root of 1 is 1 times I is I. So that's why square root of -1 is equal to I. And square root of -4, by definition, is square root of 4 times I. Square root of 4 is 2, so it's a 2I. And C, square root of -8 is the square root of 8 times I. Okay, and then square root of 8, 8 is 2 times 2 times 2, so you have 2 square root of 2 times I. Okay, square root of 8 is 4 times 2. Square root of 4 is 2, so you can push a copy of 2 outside. When you move 4 outside square root, it becomes 2. So that's why you get 2 times square root of 2 and times I. Okay? So, be careful. In this definition, we only define the so-called principal square root. The principal square root, the square root without negative sign. We never say there's only one square root. We just say the principal square root. Okay? So I see the example about this issue. Solve each equation. Okay, so in the exam, if we just say solve each equation, then all the solutions are real. If there's no real solution, then it just means the equation has no solution. If I want to emphasize you to use I, we will say solve each equation in the complex number system. Okay, when you see this in the complex number system, then you are allowed to use I. Okay, so first square root method, x squared is equal to 4. Then what is x? The x is plus or minus square root of 4, which is plus or minus 2. Okay, and well, this is a standard one. It doesn't matter it's in the complex number system or the real number system. B, x squared is equal to -9. If you get this equation in the problem with the requirement to solve each equation, then this one has no solution. Okay, am I clear? So if you only have the question like solve each equation, and then you see x squared equal to -9, it has no real solution. And that's it. But if you see solve the equation in the complex number system, you're supposed to use this definition we just discussed. So x is equal to plus or minus square root of 9 times I. Plus means you have this principal square root. Minus, you have its counterpart. So minus square root of 9 times I. Okay, square root always has plus or minus of this. Without the sign, this is so-called principal square root. You must put plus or minus sign. So it's a plus or minus. Square root of 9 is 3 times I. It has two solutions, 3i and a -3i. Like this, 2 and a -2. 2 is called the principal square root. -2 is a counterpart, the negative principal square root, right? Okay, so the solution set here is -2 and +2. This solution set is -3i and +3i. it's very important about the difference of the requirement. If we want you to use I, we will clearly mention in the complex number system. In the complex number system, you're supposed to use this I. The equation has solution. I have repeated several times. I just want to emphasize and make sure you see the difference. Okay? So remember, before this section, we have the so-called quadratic equation, quadratic formula, quadratic formula. Quadratic formula has a number, has an important number. It's a discriminant b squared minus 4ac. And we have three cases: greater than 0, equals 0, less than 0. Right? Greater than 0, two different real solution. Equal to 0, one repeated real solution. Less than 0, no real solution. Right? So, two different real solution. One repeated real solution. We always emphasize this is a real. And no real solution. Solution. Okay? Let me get my charger. Okay. But here, these two are already solved. For the case when b squared minus 4ac is less than 0, no real solution. In this case, we are going to apply our complex number system. Then we will have the so-called complete quadratic formula. Quadratic formula. The same formula, but with a little bit different explanation. In the complex number system, it's very important that we emphasize this. In the complex number system, the solutions of the quadratic equation ax squared plus bx plus c equal to 0, where a, b, c are all real numbers and a is not equal to 0, are given by the formula x is the same formula. Denominator 2a, negative b plus or minus square root of a b squared minus 4ac. And in the complex number system, we do not discuss. Actually, we still have three situations, but all the situations will give us solutions, so we will not distinguish them. Greater than 0, two different real solution. Equal to 0, one repeated real solution. Less than 0, two different complex solution. Okay, less than 0, we still have solution, but in that case, it's a complex number. Right? So let's see. Example. Solve the equation x squared minus 4x plus 8 equal to 0 in the complex number system. It's very important we emphasize this in the complex number system. If no such requirement, no such condition, this equation may not have solution, may not have a real solution. Okay. Okay. So here we got a equal to 1, b is negative 4. Be careful, b is negative 4, c is 8. So the by the quadratic formula, the solutions are given by x equal to 2a, negative b, b is negative 4, negative b is 4, plus minus square root of b square, negative 4 squared 16, minus 4a and c. It's a 16 minus 4 times 8, 32 over 2. So 16 minus 32 is negative 16, plus or minus square root of negative 16 over 2. And then we understand the negative square root of negative 16 is plus minus square root of 16 times I over 2. Well, square root of 16 is a 4, so it's a 4 plus or minus 4i over 2, and then you do the division. 4 over 2 is 2, 4 over 2 is 2. Okay, so it's a 2 plus or minus 2i. You see, this is exactly the standard form of certain complex numbers. So the solution set is 2 plus 2i and 2 minus 2i. 2 plus 2i and 2 minus 2i. So this quadratic equation has a pair of complex solutions. And well, of course, you can check they are the real solutions. Okay? They're the real solutions. So we still have the same formula. We don't invent new formula. We still have the same formula. This formula comes from completing square trick and get this. And in this old formula, we just have a new explanation about square root of b squared minus 4ac. When b squared minus 4ac is negative, we're going to use this this definition to explain it. Okay, like this, square root of negative 16. Square root of negative 16 is square root of 16 times I. Okay, so that's a slight difference, and this difference comes from depend on this sentence. The difference depend on this sentence. You have to check if you have this sentence in the question. If they say in the complex number system, then you're supposed to use this. If they don't have in the complex number system, then this equation has no real solution. That is a final answer. Okay? If they do not put in the complex number system in this question, then you will clearly say b squared minus 4ac is negative. There's no real solution. Okay? I repeated this several times, just want to emphasize how you handle this problem. And another thing you can check, after you solve it, if it has complex number solutions, then these two solutions are what? Are conjugate to each other. Are conjugate of each other. Okay? So let's still try to rewrite this quadratic characterization in the new way. So in the complex number system, in the complex number system, consider ax squared plus bx plus c equal to 0. Consider this quadratic equation with real coefficient. Real coefficients a, b, c are real, and a is not 0. Okay, then we also have 3 cases. If b squared minus 4ac is positive, the equation has 2 different real solutions. Okay, if the discriminant b squared minus 4ac is equal to 0, the equation has a repeated real solution. Repeated, it can repeat once, twice, 3 times. So here we have to make it clear. A double root just twice, right? 1 and 1, 1 and the same thing, and that's it. That's a repeat. And if the discriminant b squared minus 4ac is less than 0, the equation has 2 complex solutions that are not real. Here we emphasize that's definitely not real, because real is also complex, but here we say they are really complex. They contain the I part. And also we emphasize the solutions are conjugate of each other. They are paired. So you have 2 plus I, you will have 2 minus I. And this has a condition a, b, c must be a real numbers and a is not 0. Okay, so this is actually, if you check it, it's a repeat of the of this characterization. Only the third situation, the third case changed. Only third case changed. Okay, now let's see. We are going to have the following example to demonstrate this. So without solving it, we don't care if you really find the final solution or not. Determine the character of the solutions of each equation. Okay, without solving, we don't really find the solution and discuss the character. We just use the discriminant to write down the character. A, we check b squared minus 4ac, which is b is a 4, square is 16, minus 4 times 3 times 5. So 16 minus 4 times 5 is 20. 20 times 3 is 60. It's negative what? 44. Less than 0. So the equation, the character, and now you see the character, the solution, a complex number, 2 complex numbers. that are not real, and they are conjugate of each other. Okay, so we just copy the character. This is a character. Once you get the discriminant like this, you have the character. You have discriminant like that, you have another character. Okay, solutions are two complex numbers that are not real. The two different real solutions are also two different complex solutions, the special complex solution. Here we emphasize they are not special complex solution. They're general complex solution with I part, B 2x squared plus 4x plus 1 equal to 0. Without solving, you see here in the whole process, we don't actually check what is the final answer solution. We just check the discriminant. The character is determined by the discriminant. So it's a b squared minus 4ac is 16 minus 4 times 2 times 1 is 16 minus 8, and which is equal to 8. Okay? The positive. Positive means the solutions are two different real numbers. Positive discriminant will give us two different real solutions. And C is 9x squared minus 6x plus 1 equal to 0. Then we say b squared minus 4ac, b squared negative 6 squared 36 minus 4ac. Here this b is negative 6, 4ac. It's a 36 minus 36 is 0. You have 0 determinant, discriminant, 0 discriminant, then the solutions are a repeated real number, a double root, okay? So that's a character of the solutions. And be careful, in this problem we say without solving it, we really don't find the solution. We just use discriminant to determine. Okay, discriminant to determine. Discriminant. Let me write down this word again. Discriminant. Yeah, this word. Discriminant. It's a b squared minus 4ac. Discriminant. Okay. Okay, so we finished the section 1.3. In 1.3, the first half we solved, in the first half we try to extend our number system to a new system called complex number system. We have a plus bi. And there's addition, subtraction, multiplication, division. First three operations are simple. You just get routine way you can get it result. Division. In order to define the division, we first study the complex conjugate. And then we get the property z times its conjugate is a real number, a squared plus b squared. And then we know how to get the reciprocal of a complex numbers. After we figure out the reciprocal of a complex number, we can really compute the quotient, the division. We always multiply top and bottom by the complex conjugate of the denominator and simply do the computation. Right? So that's the division. Division is a slightly complex. And after that, we study the periodicity of the powers of I squared negative 1, I cubed negative I to 4 positive 1, I to 5 I. So there's some periodicity. Every 4 times the values will repeat. Okay, so that's the study of the first part of 1.3. And the second part, we try to apply this complex number system to the study of a quadratic equation. The reason we want this is that in the quadratic equation we have some undetermined situation. When the discriminant is negative, there's no solution, no real solution. We want to fix this error. We want to fix this hole. We invented or we extended our number system from real number system to the complex number system. And we need the understanding of square root of whatever negative number. Square root of whatever negative number. We define the so-called principal square root. With the help of the principal square root, such quadratic equation has 2 complex roots in the complex number system. In the complex number system, it has 2 solutions, and these 2 solutions are always conjugate of each other. Okay, so this is a principal square root. These are 2 complex square root. Principal square root, 2 complex square root. Okay, and that's the section 1.3. It may be new for some of you, or maybe discussed for the other part of you. But anyway, try to do practice, and if you have any question, send me email. If I make whatever mistake, also send me email. Let me clear it to other students. Okay, thank you very much. And the lecture was not done. We will continue in the next video. Thank you.